people who came down with it, usually children, quickly lost weight. They shrunk away and died within months. The onset of it was, in effect, a death sentence. The only therapy, if you could call it therapy, was to put them on horrible diets. The undernutrition diet was, in fact, slowly starving to death.
You have to remember that this is in the 1920s. There are no medicines. This is a medicine that takes children who are going to die in weeks or months and saves their lives. This was just an absolute miracle.
The name Banting is synonymous with best. You mentioned the names Banting and Best to a Canadian. Oh, of course, it's the discovery of insulin.
Frederick G. Banting and Charles H. Best are two of Canada's most celebrated national heroes, and the lead characters in a scientific origin story that has undeniable appeal. Two underdogs who came out of nowhere and cured one of the world's most dreadful diseases.
The discovery of insulin is seen as Canada's gift to the world. And it started right here in this house all those years ago. So this is the most important room in our house. This is the Banting bed, and it was here the world changed on October 31st, 1920, when Banting comes up with his idea. We let people come in and experience the room because it's that important, and we do let people sit on the bed. One time we had this gentleman, he'd been doing diabetes research for over 30 years. And he comes in, and next thing I know, he's laying down. And then he says to me, "I'm so sorry, but you'll never know what this means to me. This is the site of the greatest moment in my field. I knew I had to come here and pay my respects." And that's why you hear words like pilgrimage when people come here. Banting, he actually failed his first year of university. And when he becomes one of the most famous physicians/scientists in the world, one of his former teachers was quoted in a newspaper, "Frederick Banting, not a student on whom we thought fame would ever settle." It's actually a pretty quick story. The idea is October 31st, 1920.
Now here's the basis of my idea. We know that if you remove or destroy the pancreas, the amount of sugar in the bloodstream goes shooting up, and if you've got too much sugar in the blood, you've got diabetes.
Well, of course.
Therefore, there must be something. Some internal secretion in the pancreas which controls the amount of sugar in the blood. And if I could find
Why
that...
do you say there must be an internal secretion?
Well, it's obvious. At least that's what I want to try and prove.
Your first experiment is May 17, 1921.
If I've done this properly, you should see a nice dried up pancreas with all the acinous tissues withered away.
July 30th is that famous Banting Best in the Dog photograph. This is dog 410.
8 cc's of extract given at 12 midnight. There's no more doubt, Charlie.
8 hours ago, a diabetic dog, and look at her now.
It's that singular event, that 2 a.m. event, that set in motion this chain of events that led to the discovery of insulin when it did.
We've done it, Charlie. We've got it.
There were people who said that you can't write the true story of the discovery of insulin.
In the 1970s, Michael Bliss was a young historian at the University of Toronto, where the Banting and Best legend loomed large.
I would walk across our campus and look at the monuments.
This was where the two scientists had made their big discovery. But it wasn't hard to find holes in the story.
If you said to yourself, Nobel Prize for insulin, Nobel Prize to Banting and Best. Oh no, that's not quite right. The Nobel Prize was awarded to Banting and some guy named MacLeod.
Bliss decided to keep digging. He poured through thousands of old documents, interviewed surviving patients, and meticulously pieced together a record of Banting and Best's original experiments. The story he found was a messy one. Embellished results, bitter personal rivalries, and important contributors who'd been almost completely forgotten. And Banting's famous idea, as it turned out, wasn't a breakthrough at all.
Very early on, I was approached by a doctor who had been a student under Banting. He said, "The story of Banting and Best is a great and wonderful fairy tale, Professor Bliss, and you ought not to cause it to be shattered."
All science is an arc. Everything we do is built on everything that came before, and there's a whole branch
Jeff
of the
Friedman is a molecular geneticist at Rockefeller University. Among scientists, he's famous for his own discovery of a hormone called leptin. He's fascinated by how scientific discoveries build on one another, which is what drew him to the insulin story.
There were lots of sort of clinical milestones along the way, but the first real breakthrough, I think this was in 1888 or 89.
In 1889, researchers in Germany,
Oskar Minkowski and Joseph von Mering.
Minkowski was one of the great animal surgeons of his day.
they found that if you took the pancreas out of dogs, they immediately became diabetic.
Diabetes mellitus, which is what we're talking about, means sweet urine. The folklore is that physicians of the day would taste the urine. I'm not actually sure exactly how Minkowski decided there was sugar in the urine, but he did. That was the point at which it was clear that the pancreas had something to do with diabetes.
The next piece of the puzzle came from a medical student at Johns Hopkins University.
Eugene Opie did a really lovely set of experiments where he could show that it wasn't the pancreas itself that was causing diabetes, it was a particular structure within it.
Most of the pancreas is made up of cells that produce digestive enzymes.
And then there's these small structures, the islets of Langerhans.
They only make up about 1 or 2% of the pancreas, and before Opie, they were a complete mystery.
What Opie showed is that if you developed a disorder of the pancreas and the islets of Langerhans were preserved, you didn't have diabetes.
But if the islets of Langerhans were destroyed, you did.
So then the question is, what are the islets of Langerhans doing? And there were lots of theories abounding. One of them, of course, was that they make some factor.
Some kind of substance.
What came to be called the internal secretion of the pancreas.
That controls blood glucose. And lots of people,
Hundreds of scientists,
started to look for that factor.
but nobody was able to find it.
But that didn't stop doctors and scientists all over the world from trying to turn the pancreas into a medicine.
You would feed patients raw pancreas,
Or a ground-up extract of the pancreas.
but anybody who had some good results found that terrible things were also happening to the patients.
Vomiting, fever, convulsions.
Injections of pancreatic preparations have proved both useless and harmful.
In fact, some people are suggesting the whole hypothesis must be wrong. Banting was the first to admit that his education wasn't very good, but he was intellectually curious. One night, when he was having to give a lecture on the pancreas, he was reading in the literature and got struck by an article on blockages of pancreatic ducts. It inspired him to write down an idea, and Banting thought maybe this idea would work as a cure for diabetes.
October 31st, 1920. Ligate pancreatic
Banting
ducts.
thought that maybe the digestive juices in the pancreas were destroying the internal secretion.
Banting's idea was maybe we could ligate the pancreatic duct.
If we block the pancreatic duct, the pancreatic juices dry up,
So the only structure left are the islets of Langerhans.
and voila, we'll have the internal secretion.
Banting took his idea to the University of Toronto, Banting's alma mater, and one of the top public research universities of its time. It's here he met J.J.R. MacLeod, a Scottish physiologist who was a leading expert on diabetes.
MacLeod was skeptical, doubted that Banting's idea was practical or even particularly original.
But he had some extra lab space over the summer, so he gave Banting a shot. He even offered to hire a graduate student named Charles Best to help.
Banting and Best begin their research on May 17th, 1921, and then MacLeod goes to Scotland for the summer. So Banting and Best were on their own, doing operations on dogs in 90-degree heat. Things had a way of going wrong, dogs getting infected in the heat, running short of dogs, having to go out on the street and buy dogs. People talk about the dog Marjorie as the first dog. That's a later invention. In fact, the Toronto dogs all had numbers. Lots of dogs lost their lives. It sounds horrifying, and in a way it was. It was a tough piece of research. By the end of July, though, they found that they could make an extract of the pancreas of these duct-ligated dogs, and if they injected it into the diabetic dogs, the blood sugar would drop. And that was, for Banting and Best, really exciting stuff.
Dear Professor MacLeod, I have so much to tell you and ask you about that I scarcely know where to begin. Dear Banting,
MacLeod comes back.
the results from your experiments are certainly very encouraging. But
He's skeptical.
it's very easy in science to satisfy one's own self, but very hard to build up a stronghold of proof which others cannot pull down.
Their research was riddled with errors. They ignored negative results. They utterly misread results.
The results on dog 408 were not absolutely convincing.
MacLeod and Banting had very sharp confrontations about how much support MacLeod would give to the ongoing research.
I asked him for four things.
Immense tension and bitterness.
Professor MacLeod was not inclined to give us these demands.
Under the surface,
I do not wish to spend money at present on the old rooms.
Banting said to MacLeod,
If the University of Toronto do not think that the results were of sufficient importance, I would have to go someplace where they would. His reply was,
Dr. Banting, as far as you're concerned,
as far as you're concerned,
I am
the
University of Toronto. Best remembered Banting coming out of that meeting saying, I'll show the little son of a bitch.
But MacLeod actually had good reason to be skeptical. Banting and Best hadn't really gotten much further than earlier scientists.
In their published papers, they fudge it a lot. But you see in the notebooks, it just would not work consistently. By December 1921, they were virtually at an impasse. And so Banting went to MacLeod and said, I think we should have help. Floating around the university all that year had been a trained and skilled biochemist, James B. Collip.
Collip joined the team in December 1921. He and Banting started out as friends, but their relationship quickly soured, as Collip started making rapid progress on his own.
Collip took Banting and Best's crude extract and developed a method of purifying it. The real key is immediate chilling of the pancreas to stop enzyme action and what was called fractionation that a biochemist like Collip well understood.
Banting's idea turned out to be superfluous because Collip just ground up the whole pancreas.
By January, there was talk of testing it on a human.
Banting was thinking, I want to be sure that I get full credit for everything I've done. So Banting insisted that the first extract to be tried on a human would be the extract he and Best were making.
On January 11th, they gave Banting and Best's extract to a 14-year-old boy named Leonard Thompson.
And it failed.
But in the days after the failed test, Collip perfected his own purification method.
Collip went into the lab and said to Banting, I've got it. And Banting said to Collip, how did you do it? And Collip said, I don't think I should tell you. That led to Banting grabbing Collip, shaking him, Best having to pull them apart. 12 days later, this boy is given another pancreatic extract, and it works sensationally. All of the symptoms of his diabetes are cleared up. Collip produced, for the first time in history, a mixture of the internal secretion of the pancreas that proved itself in human tests. Something amazing has happened by any standard of medicine. But the production problem was a nightmare. They had desperate parents flocking to Toronto to look for this magic discovery, and they didn't have it. They had to get help. Eli Lilly and Company, big American drug company, begins pouring its resources into the problem of making insulin.
The science was yet to be discovered. In fact, it takes us almost the entire first year to invent the actual process. They understood that every day there was a delay, that patients died.
By the summer of 1922, Lilly is able to produce potent insulin, and we have astonishing results. That you could give this to these children and bring them back to life. It doesn't get any better than that. Everybody realized this was an amazing scientific achievement. So, who had done it? Who do you credit with discovering insulin? So the Nobel Prize was formally awarded to J.J.R. MacLeod and Frederick G. Banting. Banting was furious. He announced that he was sharing his half of the prize equally with Best. MacLeod announced that he was sharing his half of the Nobel Prize with Collip. But the Banting and Best version, these brilliant geniuses working with everybody's hand turned against them, this resonated with the public. There was Dr. Banting, the man who had the idea. Surely the idea is everything. And so Banting really was put on a pedestal.
I don't think there's any question that eventually someone would have purified insulin and made it into a medicine. The truth is, in most of science, there's not a single step. There's a series of steps. Knowledge advances, and then all of a sudden, one group builds on what came before and just makes the big advance. The people who get to make the advance often had better fortune or were in better circumstances than the people who didn't, who might very well have been able to had they been given an equivalent chance.
There's perhaps no better example of this than an American scientist named Israel Kleiner, who published this paper less than 2 years before Banting and Best started their research.
A paper that I think is just a masterpiece. He comes up with what, by today's standards, would be a completely statistically significant data set. He shows definitively that the pancreas makes a factor that controls blood glucose. I think it's pretty clear that Kleiner was describing insulin. He didn't call it insulin at the time. Kleiner understood exactly what he had. He knew what this factor was, he knew it had therapeutic implications, and even contemplated how this could potentially be made into a treatment.
But it was something that Kleiner never attempted, and this is where his story takes a sharp turn away from Banting's. Kleiner's research came to an end in 1919, when the lab where he was working shut down.
He has a wife, a young daughter. He's also supporting his mother-in-law because his two brother-in-laws had been killed in World War I. And the only job he can find is the New York Homeopathic College, which is rather antithetical to his research training and his scientific background. At that point in time, there are very few places in the world that provide the funding to do research.
Banting was lucky enough to be at one of those places, and he had one other thing going for him.
One of the things that bothers me a little bit about Kleiner, he clearly understood what needed to be done. On the other hand, there's no evidence that it was at the top of his priority list either. And that does contrast to Banting, who was absolutely obsessed with purifying this and making it into a treatment.
Banting and Best won the battle of history. In the popular mind, there is tremendous staying power of the Banting and Best myth. It's so easy to say Banting and Best and so confusing to say Banting, Best, Collip, MacLeod. Collip was the best scientist of the bunch. Within 2 years, he was one of the key discoverers of parathyroid hormone. In the late 1920s, he began work on the estrogens. Collip's students got Nobel Prizes for their work on the hormones of the brain. Without MacLeod and Collip, Banting and Best's research, I'm convinced, would have petered out in nothing particularly useful. Banting and Best would have disappeared into the mists of failed ideas. Banting never really understood the limitations of his idea. Banting always believed his whole life had been, in effect, based on this one idea that had come to him late in the night. You can see in his later research, Banting is always trying to find other great ideas so he can do it again.
But he never did.
We want heroes that we can emulate. We want heroes who can be mentors to us. And it's tougher to say, well, look, the reality is different. It's not a story about Banting, not about Best, but a story about what insulin did for these diabetic patients. The more you think about it in a way, the bigger the breakthrough becomes.
Giving myself my own insulin.
Here is science finding a way to alter the human condition.
Done.
Good job.